welcome. I'm going to discuss today CERN Education Programmes, CERN Science Gateway, and we have enough time to discuss also how to come to CERN, what to do, and so on. And whenever you have a question, as we have only 10 here, just raise your hand and we can discuss the question immediately. So, for those of you who have not yet been to CERN, just 2 slides about CERN. So CERN was created in 1954 with the motto Science for Peace by 12 European member states, and nearly all of those member states are still members of CERN, except Yugoslavia, which of course doesn't exist as a country anymore and can thus not be a member directly, but nearly all of the successor states are still members. CERN member states put themselves together in order to make civil research, non-military research is maybe more correct, on nuclear physics, which was at that point in time deemed to be pure weapons research. And since then, CERN has grown. We have currently, I would say, 23.5 member states. So we have 23 member states plus Estonia, which was already accepted as a member state, but we did not raise the flag and they did not deposit the documents at UNESCO yet. But otherwise, we'll have 24 member states. Full member states of CERN need to be European states. These are those 23 plus Estonia listed here. And since about 13 years now, we can have associate member states. They can be in Europe, but they don't need to be in Europe. In total at CERN, we are working together with more than 150 countries, nationalities, and well, you see a bit what are the states we are working with, and you also see a bit about CERN's annual budget, about how many people we have at CERN, or we had at CERN in 2022. The number of the users explicitly went up significantly again. I just remind you, 2022 was the last year of something we called pandemic. And also, it was 31st of December when most of our users are not even registered. So we're currently at around 14,000. And CERN has also subscribed to the Sustainable Development Goals of the United Nations. And you see from time to time those pictograms on my slides showing a bit what we are doing there. The users coming to CERN to perform research come at about 2/3, a bit less than 2/3 from CERN's member states, and a lot of them come from observer states. You see Russia is still there as an observer state, but its participation is suspended now, and we'll see when and if that comes back. Now, CERN, as I said, created by these European states, was given 4 main missions: fundamental research, research at the frontier of human knowledge, innovative technologies in order to perform that research, collaboration for the good of humanity, for the good of science, and that's the main topic today, education and inspiration for future generations. And you can also put there a bit the Sustainable Development Goals. Mainly this goal, quality education, is what we are going to talk about today. Just for the fundamental research, the research questions currently being considered at CERN as the main questions are the early universe, antimatter and dark matter, and on all 3 fronts there is significant research. Coming now to education, what do we do at CERN in terms of education? And let me start with training. We have lots of opportunities for students, like administrative students, that's typically bachelor candidates, technical students, that's typically master candidates. We have a summer student program, so as of beginning of next week, The CERN cafeteria will be completely crowded from midnight to midnight, and we'll have 478, I think, summer students this year coming to CERN. We have something which in earlier times we called fellows. They are now called Origin and Quest, and also research fellows still. And we are doing a lot on this front, tertiary education. We also have a lot of CERN schools. CERN schools for accelerators, for physics, for data acquisition, and so on. But is that education? Would you say what I listed up to now is education or not? Who of you would say, yeah, that's education and that's all what you need to do? None? Okay, I should have asked the question differently maybe. So, of course, my answer is no. And why is my answer no? That is because all of what I've shown is really training and continuous professional development and things like this. But it's not education in a stronger sense. So the question is, what do we want to educate? And of course, you could imagine CERN doing education in particle physics, but education in particle physics, again, is not really education. So what would you educate? And my answer to this was formulated by Ernst Mach something like 150 years ago, or 138 years ago. And to my understanding, what we should try to educate is the nature of science. So what is the scientific method? What is science at large? And if you find an earlier quote on what is nature of science, I'm happy to take it, but that's the earliest that I could find, and that was Ernst Mach. And he was really great in defining what the nature of science is, and to my understanding, what we need to educate. Now, first question, when we know what to educate, or what is the goal, whom do we want to reach? What do you think? What's our goal? Whom do we want to reach with our education programs? General audience, high school students. I like short words. Yeah, society at large. Now, the question is, can we reach everyone? No, we can't. Of course, we can't reach everyone. So the question is, do we find multipliers to do that? And those multipliers, teachers maybe? That's the standard approach, using teachers, because that's the easiest way to do. You can communicate to universities, you can communicate to countries, you can communicate to teachers, and teachers communicate to students. And there the question is which age. And those of us who learned at some point in English that there are pupils, which are young students, in education research we are only speaking about students. So in principle, kindergarten, you still speak about children, and we start with kindergarten, in fact. But afterwards, it's primary school students. So that's why I put which age here. So we reach the students through the teachers, and hopefully those students, those people in school will go back home and talk to their parents. And if that works, and their grandparents and their great-grandparents, and hopefully by that, we reach everyone. Now, one possibility, and that's the one we did for a long time, was getting people to CERN, doing visits. With visits programs, we can cover about 130,000 visitors to CERN's installations per year. Already last year, we had more than 370,000 requests. So we can't honor all of this. So the question is, how can we do things and what can we do? So you see, CERN is quite big. all those white places can be in principle visited, and we can explain things. And we do that with the help of people who are authentically working on those experiments. And then we get nice quotes like this one, which is by Tom Hanks when he was shown around CERN. And he was quite eager to look at what we are doing there. Now, 130 out of 370,000 is not a lot. So we created something recently, which is the CERN Science Gateway. So you see the whole campus of CERN here, and you see, I'm not sure if my mouse is visible on that screen. Yeah, it is. So you see Science Gateway here. Resolution is not too good, but I couldn't refrain from taking one of my flight videos into here. So that is Science Gateway. You see the globe in the center, which also is part of Science Gateway now. And there in Science Gateway, we can now host far more people coming to CERN and wanting to learn about CERN. Science Gateway in itself is a new building which we inaugurated in October last year. It's a 7,000 square meter area where our first goal was to reach 300,000 visitors in Science Gateway, additionally to the guided tours per year. If I'm not mistaken, we were end of May at 200-something thousand already. So it's quite a lot of people coming there, and we are trying to do a lot in Science Gateway. Science Gateway has a large, where's my mouse? A large auditorium here where we can have science shows, for example. We have a large education lab, and we have lots of exhibitions and also a quantum exhibition where you yourself can get into the skin of a quantum, be tagged, and go through a certain labyrinth. So when we boil that down to the education activities, we have the education labs here. We have this part with hands-on experimentation, and we have the auditorium. And the three main education activities we do at Science Gateway, covering, at the moment at least, the request, is we have the labs. I'm going to go into this a bit deeper. We have science shows, and we have some online learning connected to Science Gateway. So science shows are science shows that are educational. So we don't just want to show roses in liquid nitrogen or balloons that are breaking because they are cooled down. But the idea of those science shows is to really explain what's going on. And you see on the left-hand side, you see one show which is called a Journey Through a Detector, where you see how a particle behaves in a particle detector. On the top right, you see our data science show, where we tell especially younger kids how to deal with data, what data is. And on the bottom, there is again the Journey Through the Detector. So these educational shows also exist in a transportable way, so you can get some of them and use them also at festivals, for example. Besides the science shows, we have the lab workshops. And we have lab workshops starting from 5 years of age for the general public to 105 plus. I was told if I say 5 to 105, that's discrimination. So I believe I have to say 5 to 118 currently, but 5 to 105 plus will do. We have a lot of workshops for younger kids now. We started with School Lab, that maybe some of you know, where we did lots of things for high school students, but now we are doing more and more things for smaller students and also for the general public. Starting with this, which we call Mysteries of Matter, or Seeing the Invisible. Seeing the Invisible is a workshop where you need to find out what is the obstacle that we hit in there. Then we have one quite heavy experiment at CERN that we need to move, and we do that by the power of air. We have a lab activity for that. When we go to smaller children again, we have this. So this slime is A, magnetic, and B, changes color when the temperature changes. So to show that matter has different invisible properties. We have right of that our old standard experiment, the cloud chambers, that I think everybody who ever visited one of our teacher programs has built a cloud chamber. We are doing robotics, we are doing superconductivity workshops, there are Lego workshops for the intermediate age range, magnetism, some standard physical phenomena, and for the high school students, there is also something where we do medical applications. That is a PET workshop where you can find a tumor in a brain. Well, it's of course not a tumor and it's not a real brain, but you learn how to work with that. And as you can see, there are even bigger children who like those things. And we had, that was a state visit of this gentleman from France, accompanied by this gentleman, the president of Switzerland at the time, and our DG, who were then afterwards really playing with the children how to program robots and how to measure invisible properties. So we have 10 different lab workshops for 24 people each. In the first 9 months, we already did nearly 800 workshops with about 17,000 visitors. And as you can see, a lot of them are school groups. So the top 4 lines are school groups. That's already more than 50%. And then we have student groups and we have open workshops where we don't look at the age. This is workshops over the weekend where full families come and do workshops in the labs, which is extremely popular. Now, this is walk-in people and it's people doing visits. And you can ask the question, is that education or is that outreach? It's somewhere in between. The science shops and the lab workshops are definitely rather on the education side. We have internship programs, and we already also had an internship program for the Czech Republic in 2018. Currently, these internship programs are frozen, but we are going to redo them. These are 2-week internship programs for high school students that can come and really do a project in a department at CERN. And we're trying to redo that now. We currently have 24 Romanian high school students at CERN, and we hope to restart that. And then we come to what several of you know already, the teacher programs. So we had from 1998 until end of last year, nearly 15,000 teachers coming to CERN in either international programs in summer or in the national teacher programs in the national languages, which we introduced because, yeah, it's nice to have an international audience in an international teacher program, but lots of the teachers from different countries, they don't manage to really then pick up what they learn in these workshops. They have to transport it first into their language, and then they have to transport it to their students. And as this is quite complex, what we started in 2006 is national teacher programs. And we are currently doing 35 weeks of national teacher programs per year, and we cover in total, but not every year, 27 languages. So we hope that this helps a lot in order for the teachers to be able to be the multipliers for this education. On the other hand, during the pandemic, we started to do online programs, and we still have a few online programs. The main one that we still run is the Ukrainian online teacher program. Of course, they can't currently come to us, and we can't go there. So that we do online. And we have also started a new program, the South Asia Science Education Program, going to South Asia and do courses there. Now, teachers, let's get the group a bit wider again. Students can participate in the Beamline for Schools competition. This Beamline for Schools competition runs this year for the 11th time. It's the 10th anniversary. There, teams of students, up to 9 students with 2 accompanying teachers, can create an experiment, can apply with this experiment for beam time at one of our or DESI's accelerators, and then come and perform the experiment at PS or at DESI for 2 weeks. The winners of this year are already selected. They will be announced end of next week. And yeah, it will be 3 very interesting experiments again that will be done at CERN and at DESI. Now, I said I want to reach everyone. So what do we do about the people who cannot come? So during the pandemic, we started virtual science shows. So the idea was to use the pandemic as a great opportunity to reach those whom we cannot normally reach. So we do live science shows online. It's not taped, it's really interactive with those schools who want to participate. And we continue to do that, even though on a lower level for the moment, because we just have too many people coming to Science Gateway. Another way is to create low-cost material for the classroom. During the last day here, we discussed already quite a lot about equipment in schools. But what we tried to do is for all countries to make something which can be used immediately in the classroom, which can be either 3D printed or just procured without too much budget. Like here we have a Rutherford experiment with balls. We have mystery boxes. I guess the pointer is where the mystery box is. I have a video screen there. So mystery boxes you can do from 3 years onwards, and you can easily 3D print them or build them with Lego, which then makes it even more funny if one group of students builds a mystery box and another group has to experience it. Then we have a linear accelerator that you can 3D print. We have a particle trap and lots of particle games. Gamification is one of the possibilities to make this topic a bit more interesting. And the one that I like most here in this is this 3D puzzle where you have quarks and other particles, and they only fit together in the way that they would in particle field theory. So you cannot put particles together in a wrong way. Now, that reaches these schools that really want to do something like this. Now, how do we reach even more people? And we started the so-called CERN Education Program. And I think the video in here should start too. Yeah, but we'll do that in a second. This education program, we had one camp last week, has 3 levels, short videos in portrait mode. And why in portrait mode? Well, quite easily. Research shows us that students below 25 don't watch YouTube, they watch TikTok. And TikTok is portrait. So we do a first level of short videos, which I'm just going to start here. These videos allow home experiments to be performed with everything you have at home just, and relate to CERN technology. In this case, we are talking about optical fibers, and that's what you need. I cut the music here, but there is no other sound to it than music. Then we have explainer videos, so a complete MOOC with quizzes. And those students who answer 4 quizzes correctly can apply to a student camp. So we have about 700 applications for each camp, which normally is annually. This year we have 2, but normally it's annually that 30 students from all over the world can come and do 1 week CERN visits and working in experiments. So this student camp, the first one for this year happened last week, the next one will happen in October. And as well, the short videos, as well as the MOOC, are available for everybody. So with this, we reach, on average, an audience of 60 to 70,000 students worldwide who take at least one of those quizzes. So that's how we, as far as we can go with reaching people. Another possibility is, of course, engagement of all the other actors. So we have all of those collaborations. I think, yeah, that's all our education collaborations. And you see, I recycled this slide because that is a Swiss slide. In principle, I should have put Jirji's picture here for the Czech Republic, but I didn't change it, sorry. So there is a lot of different actors worldwide that are working on education, and we are trying to work together with them as far as we can. Now, are we sure that all of this is effective? Well, we accompany all of this by research. So this means all of the programs are being researched by a team of doctoral students who are looking at the different impact, motivation, curiosity traits. And we do that in many different ways. And I'm just going to give one research example. And this is an example where we asked the question, what should the students and the teachers learn? So the idea was to really find out, what do scientists think that students should learn, and what can they learn, and where is the curriculum link? So the methodology was quite easy. We did a so-called concept map to find out with a large number of people, I don't remember how many actually, to find out what should people learn about modern physics and CERN physics in general, and then do a curricular review. So what is represented in our member states in high schools? So the concept map is that big. It has nearly 90 concepts and examples, nearly 300 links, and it has 8 levels. So it's quite complex. And if you start looking at that, you see, if you want to understand particle physics, you need to look at theoretical and experimental physics. Experimental particle physics mainly happens at accelerators. Then you can go towards acceleration principles. Then you are on that branch here. You have then created collision, so you need particle detectors. And we tried to find out, with all those experts, what are the different aspects that we need to explain in order for students to understand what we are doing. And in the end, you come to the open questions, not only in particle physics. So the conclusion of all of this research was, particle physics is a topic with which we can start to handle other modern physics topics, and particle physics can be connected to other topics in a curriculum. Now, the question is, how extensively is particle physics featured in high school physics curricula? So we looked at 27 high school physics curricula with 2 independent reviewers each. And you see already on the map that not a lot of countries mention particle physics explicitly. And I think we did not research the Czech Republic. I think that looks gray on here. I don't know why. And we have a lot of countries with an explicit mention and without an explicit mention, but when you look at that a bit deeper, then you find that these concepts do not mean that there is nothing of this in the curriculum. So you see, history of particle physics is far more mentioned in countries where you don't have particle physics in the curriculum. Because they just don't talk about the content, they just say there is particle physics and it has this history. The same of quantum physics. And when you look at nature of science, which was the goal, if you remember, then you see those who really look at particle physics, then you also talk a bit more about nature of science. So, that was one example. I can show you more later in the discussion if you want. And if you were asking how many people are working on that, this is, as of this morning, because that's when I counted through, the size of the team that is doing education at CERN. And you see we are quite distributed in countries. And yeah, that's the team that we have. And we are always looking for new collaborations. So whenever you want to collaborate on particle physics, physics education research, and how to convey what we are doing at CERN, just come to us. And I want to end with a slide of Science Gateway with one of my favorite quotes of a 4-year-old girl talking to one of our guides after having been at Science Gateway. The picture was done by ChatGPT, in fact. Unfortunately, at CERN we don't have uniforms or things like this, so it made a NASA uniform. I would have put an ESA one, but that is probably too much ChatGPT. But this is essentially the goal of all of this, and that's the goal why we are doing all those things. And now it's time for your questions and for the discussion. I have some more slides for discussion later if you want.
Okay, thank you.
Thank you.
There's really room for questions, so please ask.
I would like to ask whether there are any opportunities or possibilities for students who are kind of passionate for biology and medicine, especially
at CERN in general, definitely yes. There are experiments looking into medical applications. There are experiments that are looking at particle treatments, at medical imaging. There is possibilities in our knowledge transfer for that, and actually the biologists that I know that are at CERN, they mostly work in radiation protection, and they are looking at things like this. Yeah.
Okay, thank you. I just forgot the hint that we should use the microphone in order to transfer to the outside world the proper question. So the first question was about biology and medicine application and activities, and that's in CERN. So next question.
Okay, I have one. It's fine. Okay, so I have a question. So near globe, just next to point 1, there is also this like a incubator, or what's this new facility? So is this somehow connected and used for education or training or?
Yeah, so you're talking about Idea Square.
Yeah, Idea Square.
Which is not a new installation, actually. Yeah. It's 13, 14 years now that it's there. But it started with an EU project. And it's kind of a design factory. So you have lots of possibilities for co-creation of activities there. And we are starting to more and more use it for longer-term education projects. So the Design Factory network, where this is part of, they are doing lots of co-creation developments with students all over the world. They have programs that are called CBI, Challenge-Based Innovation. That means they take a challenge, say, from the Red Cross, from any other organization, and then with an interdisciplinary team of students tackle that. And what we are trying to do more and more is to do also with student groups prototyping of their ideas. So for example, with the Beamline for School students, we go there partially and let them prototype things there. It's a very open co-working space where we run internal programs, but also programs for the EPS, for example. So the Technology and Innovation Group is doing some training there. And also there are hackathons happening at Idea Square. And Idea Square recently, as it is now outside of the fence, is also part of Science Gateway. So we are trying to do more integrated programs with them. Yeah.
Thanks.
Thank you. Thank you. Another question? Yes?
Is there any possibilities that me as a person, I can go to see like LHC?
As a single person, it's quite difficult. But if you come with a group, that's more possible. A visitor group needs to be 12 plus, 12 to 48. Normally, you have to decide about 9 months in advance, because that's more or less the time where we are booked out. The LHC is a bit difficult. So the accelerator itself, rather no. The experiments down in the caverns in winter and during a long shutdown. So the next long shutdown will be 27, when we have then a longer time the possibility to do underground visits. Otherwise, in winter, for about 2 months, there are underground visits. And you can go and visit Atlas, ALICE, LHCb, and CMS. CMS, you can go into the underground all year, but you cannot go to the experiment itself.
Okay, thank you very much. But I have another question to you. Could you briefly describe your situation, because you are going to CERN?
Yeah, well, okay. I'm glad you remembered. My situation is that I got an internship into CERN through my university. So I thought like it would be nice to have a kind of a hands-on experience and to see what I'm working on.
What do you mean by you got an internship through your university?
I got an internship for being working on the production database on Project Atlas.
Okay.
So,
and you will come as a user then?
Yeah, no, I will come as a student. I'll be working on the production database to maintain it and do the front-end side.
Okay.
So I thought maybe, is there like any possibility for me as an intern to go actually in person, because I'll be working on the whole internship through the remote office.
You will work from here?
Yeah.
Well, the first stage is getting to CERN. You have to discuss with your university. There, I can't really help you.
Okay.
If you are working on one of the LHC experiments and you have the appropriate safety courses, then also during the year, we have several times per year when we are doing some maintenance on the detectors, on the accelerator, where you as a member of personnel then can go down anytime during the year.
Okay. Okay.
That works.
Okay,
yes.
Thanks. It's nice.
Okay, thank you.
So you would be a very special visitor.
Very special. Okay. Another question? No?
Over there?
Yeah.
I would like to ask, how do you decide who gets to visit CERN? As in, like you said, there's a great overhang of people, and you have also mentioned some quizzes, but how do you decide who gets to visit CERN?
So if we talk normal visits, so visits to half-day visit, for example, then it's really a first come, first serve, with some quota issues. So this means we open the visits for the installation. So Science Gateway, you can just show up and go to Science Gateway, go to an open workshop, go to a science show, go to the exhibitions. That you can do Tuesday to Sunday from 9 to 5, more or less. If you want to do a guided tour somewhere on the premises, then we open this exactly 9 months in advance, and every day we open it at midnight. And you see there are schools who know that by now. And so between midnight and midnight 30, there is lots of people clicking there. Now, in principle, this is first come, first served, but we have a weekly quota on languages. Because all of our visits, we try to do them as authentic as possible. So it's volunteers doing those guided tours. And the number of volunteers per language is varying quite a lot. So we are trying to balance this out a bit, but also we are trying, when we accept a visit, also to have a chance to have a guide in that language. Because especially for school groups, say a Portuguese school group or take a Greek school group, doing a visit in English doesn't really help. Yeah? Then you need the teacher to translate, or at least somebody to translate. That doesn't work. So what we try to do is to make a quota by language. So I would guess, yeah, it's an educated guess, that if you come with a Czech language school, that your probability is relatively high that you are accepted, because there is not so much demand. And we have a significant number of Czech language guides. So the probability that you are accepted there is a bit higher than when you say, okay, I'm an English-speaking school, and then you are really in this first come, first serve and quota thing. I can tell you from own experience, if you try with a German group, you have a severe problem, because we don't have enough German-speaking guides, for example. So French, English, and Italian, we cover quite a lot. So there, it's just we try to keep space for the others. But yeah, that's the whole thing. Be on time. But I tried to, day before yesterday, I tried to find a visit slot for a group, an English-speaking international group. And actually, I even found still a slot in the month of June. So it is possible. But if you really want a specific day, because, for example, your school has over, I don't know, Ascension, a long weekend, and you want to go to CERN and you want to visit on the Friday, the probability is relatively low that you get that, because half of Europe has a long weekend then. So just try. If it's a day in the week without connection of a holiday concentration, especially summer holidays, it's very probable that you also on a shorter notice get something. If you are fixed on a date 9 months before, to the day.
Thank you.
And that applies to schools and student groups. Yeah, so we can usually not make too many exceptions for universities. Universities get a bit better coverage because usually they put their students into a bus, they bring their own scientists with them, so by definition they have a guide with them. So that sometimes works even on a week's notice, we saw that. But again, when you are in a peak period, it's getting tough. And I guess your university wants rather to do atlas visits, which are, in the term of underground visits, the most complex of all, because a group is only 6 people going down together. And then if you want to get a bus down, you need 8 hours. And that's just a long time. So at CMS, you can go down with 48 at the same time. So it's a bit different what you want to see. So also look at the website, what are the different possibilities, what you want to see. And maybe be open for things. Maybe a visit to the antimatter factory or to the computer center is easier to get than an atlas visit, for example. And then if you say, I want to definitely visit atlas, the slots are smaller. And that was, I think, too much insight. I mean, you're recording that, so.
Okay, thank you. Just maybe one comment, because we organize quite many times visit with small group of teachers and say interested people, and the group was typically say 15 to 20 people, to reduce the number of small groups to visit experiment and to use the break-in performance of accelerators between say Christmas and say early March or so. And this was for several years, and it may continue. And I guess that Martin already also organized such a group 2 years ago or something like that. Yes? Or, yeah.
It was during pandemic actually, but I took only a bunch of like our undergrads from the department.
Yeah. And then I don't know whether you know what is the number of visits organized by visit office from Czech Republic, because my guess is small units or at least small tens, maybe during a year.
I don't know the number, but I can look it up in just afterwards. Just one more trick: if you come by bus, have your own bus, your possibilities get more. Yeah, because we don't have buses in the visit service anymore. So if you come with your own bus, you can visit, for example, the neutrino installations, so the preparations for the Dune experiment in Prevcin in our second lab, which you can only do when you have your bus. You can visit SM18, where we integrated all the magnets for the LHC. You can visit on the Prevcin side the AMS control room, and maybe even witness a spacewalk of astronauts on the ISS. You can visit the CERN Control Center, for example. So if you come by bus, and I think coming from Prague by bus is not so difficult. We have groups from Finland coming by bus, so I think you're about halfway of that, so you might be able to do that. And then your possibility of seeing interesting stuff goes up quite a lot.